So Gary, this is quite a house, I got to tell you. I know I've seen your work before, and it's just extraordinary work, but nothing like this. Tell me, how long have you been building in the Aspen market and the snowmass market and these really interesting mountain locations like this?
Well, we started about 20 years ago in the early 90s up here, and we've built a variety of levels of homes during that course in time, starting really down in what was considered affordable in the Roaring Fork Valley, homes that were in the $200,000 and $300,000 range.
Wow.
Today, of course, those homes sell for more like $1 million, or in that range.
Sure.
And sometime in the late 90s, we decided that it made more sense to move up and I guess maybe have a little more fun with the building process and do the higher end, because there's such a demand for that type of product in the area with the ski in, ski out and vacation home market.
What would you say is the most important element of mountain architecture now in the most modern vernacular of it? Is it a combination of historical styles, or is it something that's cutting edge, or is it still very mountain lodge driven, or what? How do you feel about that?
Well, that's a good and interesting question, and we contend with that all the time. You know, after we complete the last project, we're thinking about what's really appropriate for the next one, and. As you mentioned, we've built the old lodge style homes and old world stylings and so forth, and clearly, and what we're trying to accomplish in this house is a blend of the contemporary with some of the mountain and rustic elements. So we still want to maintain some beam work and perhaps some rusticated flooring, old recycled and wide flooring and so forth, but we want to blend that with more contemporary elements, clean lines, just a little simpler degree of finishes.
I see.
And so and that's been an interesting challenge for us here with this home, is just trying to determine what elements are going to be contemporary and which ones will be rustic, and how can we effectively blend those in a real tasteful and aesthetic way. Sure.
Well, I know that you incorporate a lot of local and regional material, and especially when it comes to masonry and stone. There's also a lot of metal edge in the product today, and that wonderful rusted roof look, and some real interesting aesthetic elements. But I notice in this house in particular, I'm really taken by the amount of engineered wood product that you have, and I'm seeing it not only in the decking and sheet materials, but I'm seeing it in the studs and plates, I'm seeing it in the headers, I'm seeing it in the structural elements, and then I'm seeing it in the architectural elements. Like to the untrained eye, you would think that this is a rough sawn beam, but this is actually an engineered glulam. What was your thinking here, and how does this give you an advantage?
Well, that's right. First of all, we really have enjoyed working with the engineered lumber, and there's, as you've noticed, there's probably 99.9% of the lumber in this house is in fact engineered, and some of the advantages of that obviously are that we're using a recycled product. It gives great strength. It's very true and straight. The framing crew really loves working with it for all those reasons.
You don't have a waste pile.
That's right.
Everything is usable.
Absolutely. Our waste is reduced on this job so far, and a big part of it in this lumber, the framing aspect, has been reduced by probably, I'd say, 75 to 80% of what we might have experienced in a different type of home.
So you have the structural integrity, and you have the very good environmental story about totally using the tree right down to the last piece of sawdust.
That's right.
But what about this aesthetic where you've got these great adze marks and the distressed look on these beams and everything? This is finish work. This is going to be something that's special in here.
And this is an example of what I was referring to in trying to blend some of the rustic elements with the contemporary. And in this case, we've taken what might normally be seen as a contemporary item, being a glulam beam. Usually you'll see them finished in a slick and refined way. And we wanted to again keep some elements that had a little more character, a little more texture, and so still wanting to use engineered lumber, we decided to take the glue lamp product, and we've put our painters who have a lot of talent, and we've allowed them to wire brush and raise the grain, put adze marks into it, and just kind of emulate a rusticated, worn beam, and so that's one of our nods to the rustic elements.
But still kind of cutting that fine line toward a more contemporary feel, and using a modern building material.
That's correct.
So that you are kind of on the edge and setting yourself a little bit apart design-wise. What about basically like at the foundation level of the house? Anything special? I know that you have had to build in some pretty difficult terrain over the years. You know, either steep or rock issues or both, and then there's water issues. Now here in this particular project, and we'll get around to looking at the outside and the setting and that sort of thing, which is extraordinary. But what were the specific soil conditions and the kinds of things that had you concerned, and how did you treat those? How did you deal with those?
Yeah, well, that's interesting that you said that, because absolutely the last half a dozen homes we've built have been on hillsides. They've been in very marginal soils. We've had to over excavate the soil and bring in engineered fill. We are always dealing with water issues and so forth. And one of the beauties of this particular site is that it's relatively flat. The soils test came out with a very workable, strong supporting soil. No real problems that we had to mitigate. And with the design of this home, it was a fairly easy foundation task, and one of the things that we chose to use, again, in trying to address our desire to be sustainable and build as green a home as we purposefully could, is we used the insulated concrete forms
for your foundation
for
walls?
Our foundation walls.
I see.
Yeah, and we don't have a full story undergrade as you might have in some areas here. We have a crawl space. The crawl space has been put to good use, housing most of our mechanical equipment. But what we've done is to pour standard footers. We use the ICFs as a foundation wall system. And one of the beauties about that is that our framing crew can easily form pour footers, stack the foundation block. They're very simple to work with. We've been able to, again, carefully calculating our needs, limit our waste. The framers, my supervisor and the crew, utilized some of the leftover styrofoam from the blocks, and they sandwiched it within some engineered wood products and made our exterior headers to help insulate that portion of the exterior
resource
envelope.
Efficiency just carries over.
That's right.
Well, so like the insulated concrete form, now that gives you structural integrity and gives you engineering predictability, but it also gives you a very well insulated stem wall foundation, so that your crawl space is very well insulated, and then it makes real good use of the concrete, because you're reducing the actual amount of Portland cement-based product, concrete, that you're having to put into it. You're getting the same structural integrity.
That's right.
But you're being more resource efficient with it. Yeah,
and a very good point, because our cross section of concrete is a couple of inches less than it would be if we had used standard forms.
I see. Okay.
And so that is absolutely a benefit.
And then that translates all the way up. I mean, you take that right from the very beginning, where you're in the bottom of those trenches, and you're taking that concept all the way up through these other products. Now, tell me, what do you think is the most innovative, besides this extraordinary shell of insulated material that we see here on the building envelope? I can see a lot of innovation that I want to know about on the glazing system and on the insulation system. What do you think the most innovative part of this whole project is? Is it the choice of the heating and cooling system, or is it a combination of things?
Well, yeah, that's a tough question, I think. I'm not sure if I've considered what might be the most innovative, but there's certainly a lot of aspects that we've employed here that are exciting to me. And the sheer number of different type of products and methods that we've been putting this together, and some of the design issues that have to do with the mechanical system have been exciting to bring so many components together in one package. And certainly it's the most probably far-reaching or ambitious and sophisticated project that we've dealt with today.
Well, let's talk about the team about that, because I know that you work with one of the most innovative and highly respected architectural and engineering firms in the country in terms of sustainability. And I also know that, like all successful builders and developers, you've aggregated a group of really high-quality craftsmen. You've created a gathering of craftsmen here that have a lot of time with you, and you've worked together closely. And the little details around where I see how there's space left for the drywall to tuck, so that you're not having to do ugly, nasty seam work and those kinds of things later on. It's well anticipated, but that takes a lot of coordination. So what would you say, for you personally, is the most challenging part of taking what is already a very demanding product to a level of sustainability that you're trying to reach here? Is it the new product? Is it incorporating that thinking with the various people that have to be involved? Because there are dozens of companies that are working on this house.
Yeah, I think it is. It's really trying to coordinate everybody's thinking towards the goal that we've set out for ourselves, to create a super efficient, really green product to meet the guidelines of the LEED program, for instance, that we're working under.
Sure.
We have some inherent guidelines that Pickens County establishes in the first place, but I think it's really getting everybody on board with the concept. And it's the construction process, it's keeping and maintaining the level of quality that our crew is really used to working with and understanding, but it's also getting them to really buy into the idea with recycling our waste, limiting our waste, just being more efficient and just in the day-to-day building process, the application.
What I'd like to do at this point is have you kind of show me some of the other specialty things, because I know that there was a little bit of a learning curve, a little bit of a ramp up for some of the other trades.
Absolutely.
So, for example, can you tell me a little bit about the insulation package?
Well, this is an exciting product, and we have used a sprayed-in foam insulation that typically in the roof deck we have often coupled that with a fiberglass bat. And what we've done differently in this case is that we'll come back and look at some of it in here. We did a lot of research, first of all, and worked with Stace and the EDI, his firm, and with our engineering consultants, and we really did a very thorough investigation about the building science of dew point, and making sure that we are going to put that dew point to the outside.
Well, now, are there special climate considerations? Is that sort of the point of that?
Well, it really is for this area. Of course, Colorado is famous for its sub-zero temperatures and harsh winters, and we were fortunate this year to have a little milder one. Last year was a record for the past 40 years, and we've seen what happens up in this climate so often, and that is a combination of ice damming and just tremendous problems and damages that can occur from an improperly constructed roof with problems with ventilation and so forth. In this case, we've chosen to go with a non-ventilated roof, and we're able to do that by using this kind of a product. And
so that means that any attic space you have, or any space in the trusses and so forth, is actually inside the conditioned space.
Inside the conditioned space.
Oh, okay.
That's correct. So we're insulating to a great degree. There's something close to to 8 inches of closed cell sprayed in foam.
Wow.
And that by itself creates an R factor of 50, roughly 55.
Wow, that's substantial.
55, 56, something in that range. It alleviates the need again for ventilating, and because of the properties of this product being water impermeable.
Essentially airtight too.
Airtight, yeah, absolutely airtight. So interesting to watch them spray it in as it flows and expands and fills every crack and crevice, and really truly makes just an incredibly tight envelope. We typically have not gone to the extra expense in the past for placing it in the walls.
I see.
But in this case, we thought that made a lot of sense, and I'm happy to say that seeing the results of this and the overall design that we've come up with, the system, we're referring to using various components together in one situation, and in this case we have the sprayed-in foam in the walls. We have a rigid board of insulation wrapping the entire outside to create what is really a super insulated envelope, and that also functions as a thermal break, bridging across all the studs and the outside sheathing and so forth, and the combination of those has afforded what is really again a super insulated and airtight environment.
So it allows you to control then through mechanical ventilation and deliberate ventilation then the airflow, air exchange in the house, not only for temperature control but for humidity and for air filtration and those kinds of issues.
Absolutely.
And so then with the sheathing layer that you have on the outside with that insulated skin, if you will, on the building, coupled with this airtight seal on the inside, and then what about your glazing system? I assume that you've had to really put a lot of consideration into the U values and R values of all those components.
That's correct, and in this case, again, with a lot of study and evaluating a number of different products and so forth, we've chosen a glazing that has a really low U value that was factored into the calculations along with the other products, and so we've together created just again a very tight envelope, very efficient envelope.
And I think most people would underestimate just how much thought process has to go into something like windows, because if you're in a let's say you're in a hot tropical climate and you're trying to keep that solar gain out, that requires a certain set of components in that glazing system, whereas here you have much more of a heating scenario because of the winters and so forth, and the summers do have some bright days and solar gain, but that's not your overriding consideration.
Yeah, that's right. That's right. I mean, you're right. We have to be concerned about to a certain degree because there's no question that the south-facing windows will create a certain amount of heat gain. And the fact of the matter is that it used to be up in this country that air conditioning or refrigerated air, however one terms it, was never necessary. But the years have told us differently, and it's quite common, and so we have included that feature in with our mechanical system in this case.
Well, now you just made me really curious. Is that a change in consumer perception, or is that an actual change in weather patterns, or a combination?
I think it's consumer perception, really, is what it is, and I think that was exacerbated by the fact that in the past there weren't the kind of energy value or envelope construction that we're seeing here, the kind of super insulated and well designed envelopes. So I think that it was a combination of things, inferior products and an idea that this climate did not require such a feature, but clearly that has changed, and so.
Well, of course, you would deal with not only the building science and the technology, but then back to basic the building orientation and the siting relative to where you're impacted by predominant winds, the solar gain, and then winter weather as well. Tell me about that. I mean,
yeah, this and really that gets to one of the questions we were talking about earlier. Is, you know, the siting and the choice of this location. First of all, we're sitting in a rather flat and open site. We have tremendous views that are out predominantly to the south. We had to actually compromise slightly on orienting for the maximum solar effect, but we did that in the favor of capturing the kind of views that were afforded here on this site. And those are some of the kind of compromises that you need to consciously make. But it was evaluated with great care.
So, you know, we were talking about orientation and siting, and you alluded to the fact that, you know, you're out here in kind of an open place and you have these wonderful sort of 360-degree views. The vistas are great, and you don't have obstruction. But there's another side to that, which means that you're also at the mercy of the elements. And I noticed that, you know, like for example, the garage is placed on the north end of the building. Is that a deliberate attempt to sort of buffer some of the winter weather?
Yeah, you hit it on the head. That's exactly what that is. We have very strong winds that come out of that side, kind of on the northwesterly direction, and so that was a very strong consideration to how this was configured. It kind of worked in with a few other factors with the site plan coming in off the driveway envelope and circling into the front of the house. Obviously, we wanted to face the home south. We've got a solar array that we're both for solar thermal and solar photovoltaics that we needed to amass on the roof area. So we've tried to take advantage of the best orientation for those reasons, aside from, as we said a minute ago, trying to angle for the best possible views and create the view planes that we've been able to realize. But that was, I think, a really thoughtful decision in terms of buffering those winds from the house.
I see.
And it's been very effective even during the construction process in doing so.
Yeah, because there's not a big stand of trees or anything else that helps to, you know, break that or buffer it.
That's right.
The view corridors are paramount. I mean, in this kind of a market, in this kind of a setting, I mean, that's why people come here. And then the other considerations, because you're kind of first in here on this particular project, you have to kind of anticipate where the next houses are going to be, and so you want to be sure that you're orienting in a direction that best preserves your views and the values for your customer. And then, as you said, talk a little bit more about that access and egress, about how you transport people in and out of the property, so to speak. Was that a big consideration? Because I know there is a little bit of variation in the topography, but it's not particularly challenging for mountain country.
Yeah, it's not so much the topography that dictated, you know, what we did here, because again, it's a fairly flat site. But with the kind of controls that are placed on through the land use approval process, there's a number of items, and there's a lot of criteria that we have to live within. And there's a very strict building envelope. What's now called an activity envelope. We actually had to go back through the land use process to expand it so that we could accommodate our geothermal loop field within the confines of the building envelope. The same with our very sophisticated and highly engineered septic system. And then the driveway obviously had just one point of access, and so with the orientation of the home that we settled on for view and solar orientation purposes, it brought the driveway in somewhat off to the end of the home on the far end, down closest to the garage, and it really dictated, because I wanted a driveway that would allow us a drop-off point at the entry, so that you could swing in and actually you know, drop off and access, enter the home, or park out there. What we've done is we've created a circular loop there, and then brought it on around to the backside of the home.
And all of that with all of the prescriptive elements that you have from the county and the other regulatory bodies, as well as considerations for fire access and rescue and that sort of thing, and then permeability and trying to control runoff, and you know, there's a good deal of precipitation, and then snow melt and snow removal and all those kinds of things. It's a fairly complex scenario to try to work through and still be creative, to try to sort of be on the cutting edge of all the creative development that you have to go through.
Yeah, that's right. There's a lot to think through, a lot to address in that respect. One of the other things that we one of the reasons that we're sitting on this site as opposed to the others, you noted that we're the first home to be constructed, and this is a 5-lot subdivision that was a long time in the making. We're what we call here free market lots in an area that otherwise has a number of deed restricted homes as part of the approval process for this overall subdivision that are found on the lower benches.
I see.
We're sitting on a bench that's probably 800 to 1,000 feet above the river. There's 3 or 4 benches on the way to this one, and before we look back over all this really nice wide open pasture. But what's particularly interesting about this lot, with the series of ponds and streams that we enjoy looping through the small subdivision, is that this one has the nicest proximity to the pasture, and so we get to really enjoy the best of both worlds, with great views out over the 4 ski areas here that make up the Aspen skiing experience, and the several 14,000-foot peaks that we can look out upon, but also then enjoy this pastoral setting to the backside.
Well, now that's going to be preserved, right? That's an easement that will remain in place, and so you have that buffer, that cushion.
That's right. We're sitting on a 2-acre lot, which is typical to most of these in here, and then we have another several hundred acres of just dedicated open space back there.
So the occupant then has hundreds of yards of open space before they get to that next level of view, and the hillsides beyond, and then ultimately the horizon line at the peaks. Did you tell me that there was a prior use to this project? This wasn't just pristine mountain pasture. This had actually had some agricultural or recreational use?
Well, it actually has gone through both of those things.
Is that right?
It has been a working farm and a ranch. It also was, for a short period of time, a dirt racetrack.
Horse racing?
No.
Auto?
For small
motorsports.
Motorsports for small. I can't think of the right term for the small cars, but they had run track out here at times.
I had no idea.
So it's really interesting to look over now. As you see, it's been redeveloped.
So in a sense, it's a redevelopment project, and in fact, what we might term as a gray field, one that has had a prior use that is no longer applicable, and then so now it's being put conceivably to a higher use.
That's right.
Oh, yes. Very interesting.
Yeah.
And you're on private well system. This is a private water system or a community well?
It's a community well.
Okay.
Yeah, there are actually a few wells that are down into the I don't know. I understand 5 or 6 or 100 or even as much as 1,000 foot in depth that are scattered that feed this system, and they create a metro district in this area, and the metro district typically takes care of water and sometimes roadways and so forth. But this particular system feeds all of those areas that I mentioned earlier that are part of the various filings of this subdivision.
And then you're on private septic systems.
That are private septic.
Now you're doing something kind of more advanced in that arena of waste treatment too.
We are, but
no, it's okay. It's okay.
Stop. That's fine. Fine rolling.
Okay, now another thing that I want to ask you about, because I think it's really interesting, are the new technologies for water distribution and for the heating that you have in the house. Is there an area that you can show me that?
Well, as a matter of fact, there's a really good spot upstairs that I think we could stand and look at and talk about it there.
Sounds good.
Yeah.
You were going to show me one of the heating zones.
Right,
so we could...
right. And as a matter of fact, as we come around, this is a good example of
now what do we have right here specifically?
This is a manifold of heating loops, our hot water heating loops that are, it's zoned throughout the home to different areas. This is feeding across the wall here into our guest master
So
bath.
this is a distribution point for a specific living space.
That's correct.
Okay.
Yeah, and this system is powered from our geothermal system, creating the hot water. This our primary heating for the system. It happens to be proven technology. This is the class of the technology, and it provides just a very comfortable type of heating that I think most people would agree is really well, not only very comfortable but also extremely efficient.
So completely quiet. Has a warm to the touch, no air movement, so you don't lose anything there, and you're actually heating a mass of space rather than air.
That's correct. We have a lightweight concrete poured on top of our floors, and then again we're standing on, what we do is we cover it again with a piece of engineered plywood as a final layer, simply to give a better substrate to wood flooring or any other flooring materials that we choose to lay on this.
And then I see there's
basically this water is sitting in a mass of concrete, which helps it to be that much more efficient by heating up that mass and needing very little adjustment. In fact, this is the kind of a system that you would not come in and turn your thermostat up and down. You basically set it and leave it.
So you get that nice even heat.
Right.
And I noticed there's a pressure gauge on here. So this is actually installed under pressure so that you assure that there's no leaks in the system.
No leaks in the system.
Now you also alluded to the fact that the PEX technology is not just in the heating system, but actually in the domestic water supply for potable water throughout the house. Is that right?
That's correct. And so one of the most exciting aspects of that system to me is under normal circumstances, we would typically run our hot water loop and return throughout the house, engaging all of the fixtures and so forth as it runs from bathroom to bathroom and to kitchen and on around. And what
now wait, that would be though a continuous flow where you had a pump driving that water, and so that's consuming some energy all the time. But the whole purpose of that is to deliver within a very small volume of water, hot water at the tap, right?
That's correct.
And that's actually considered a fairly recent innovation in construction, but you have something that's more advanced than that?
Well, yes, and it's something that is really in demand, especially in a home of this caliber.
Okay.
But what I find with this system that Uponor has engineered is that we have a main circuit of water that's looping through the home, and at each bathroom or wet location there is a manifold that stubs off into service those fixtures.
All right.
And for instance, in the bathroom that we're standing next to here, what will happen when all is installed is that as a body walks into the room to use it, a motion sensor will pick up that entry and will turn on the system so that the hot water will then feed into that particular zone.
So this is automated. It lies in wait, ready for somebody to possibly demand that hot water.
Mm-hmm.
And when you go in there, it activates the circulation so that it's available to you, but it's not just using energy all the time.
That's right. It's not.
Wow,
it's just an energy saving system in that respect.
And that's integrated with additional.
And we have also integrated that with our what's called an HRV, or a heat recovery ventilation system.
Now, how does that work?
We have two of those in this home. One is strictly designed to create air changeover and temperature and humidity in the crawl space. We have a tempered crawl space, but we have to monitor the humidity levels and so forth, and so it will sense and kick on, and it will bring in fresh air as needed. It will take out old, stale, or moist air, but it also will, part of the heat recovery is that it has a heat exchanger where those two airflows pass, and it will pick up the fresh air will pick up the necessary heat if need be from that air being exhausted.
So you're not bringing in 0-degree air from outside and introducing it into that environment. You're actually warming it with heated air or heat that would otherwise be wasted.
That's precisely
Wow,
right. And then inside the home itself, we have all of the bathroom exhausts. There are a couple of standalone for various reasons, but most of those throughout the rest of the home are connected, so that when that system is switched on, we have airflow evacuating from the bathrooms and other locations in the house, so that we can likewise create an air changeover that is just part of creating that healthy home interior air quality.
Right.
And again, with the heat exchanger, helping to temper that air that's being brought in from the outside.
So as we talked about before, the fact that the house is so tight, and you have the air barrier and insulation that you have and so forth, it's critically important then that you mechanically and very carefully and deliberately do that air exchange, so that we're keeping fresh air for breathing and we're removing any toxins that are in the air and so forth, but we're not sacrificing a lot of energy and having to take again that winter air from out there that might even be below zero, and having to heat it from that
point to bring it up to temperature.
Yeah. So this gives it a little bit of a step up on the way in.
That's right.
And it's automatically controlled.
Automatically controlled.
Oh, that's amazing.
And again, with the indoor air in the house itself, we also have the humidification factor, where we're either adding humidity or pulling it out as need be, depending on what those levels are sensed at and how we set them.
And that's being monitored all the time. So if you have a lot of human activity and a lot of breathing and a lot of evaporation for that reason, or showers or laundry or other activities that are going on, that may have an effect. And then on the other hand, I know in the wintertime the natural humidity levels here can be very, very low,
extremely low. Very, very low.
Okay.
So most likely we'll be increasing that humidity level in the house throughout those winter months.
So you avoid those nasty shocks when you walk across the room and touch a light switch, right?
Right.
Wow, that's really, the technology is almost more than you can get your mind around sometimes, and yet I think you were telling me that your various subcontractor groups had really been embracing getting to know these products, because it creates higher demand for them if they're up to speed on these new technologies.
That's right. And that's been heartening to me to see that, but really exciting for all of them. Our own crew members and all of our subcontractors have been very enthusiastic about what they're seeing here, and I have to credit them, some of them, with being very patient, because a lot of this has taken us some time to research and think through and feel like we're really doing making the best possible decisions and choices, and sometimes that's caused them to stand back and just slow down just a little bit as they've waited. But again, they've all been very excited and really happy to be at work on this project, and it's showing in the workmanship.
So it's not like the old days when the plumber had his purview and he was just concerned about one thing, and that was getting water to the right place and getting wastewater out, and then the electrician had his territory, and that's all he was interested in, and the HVAC guy was interested in his stuff. Now what we're seeing is that those guys have to understand each other's work. They have to understand these things as a system, because that's really what a building is. And I think that sophisticated builders and developers and design teams like the ones that you have are really leading the way into that. Is that something that is you think critical to succeeding at this level of the market, and is that what you're trying to accomplish here?
Well, absolutely is, because as you just alluded to, all of these trades have to work together. We have so many integrated systems. All of these systems are controlled, whether it be at the domestic hot water, the radiant system. We have some secondary air heating and cooling. We've got all of these coming together with of course, there's electrical connections between all that, and we're pulling those into a whole house automation system, including our lighting and home audio and visual equipment and systems. And so there's just so much integration anymore that everybody really has to be on the same page.
Yeah, these things aren't in isolation. You've got security systems, and you've got entertainment systems, and then you've got monitoring systems for landscape irrigation and all those kinds of things. But they have to come back to a central control and understanding of these things. And what we're really talking about is an integration of how we deal with resources, whether it's the energy resource or the building material resource or the water resource, or how we deal with the waste flow from the house during the time that it's occupied, et cetera. So each one of these guys then can't live in isolation anymore. He's really got to be part of a real team.
Part of the whole team.
Yeah.
That's right. And really that's what this house embodies. It's a growing, living example of that whole concept.
Yeah, and it's advancing the knowledge of a building as almost an organism. That it makes it exciting.
Yeah, that's right.
Wow, this is wonderful. Thanks.
Yeah.